Hello friends, welcome to my channel IT Career. I know you guys are doing excellent. I'm also doing fine. I have some problem and I have some complaint on you. It's not a complaint, but I'm little disappointed. I see that you guys are watching my videos, but you know what? You're not sharing my channel with the people, and also you're not subscribing it. So it is little disappointed, but it's fine. I know many of you are just watching. You don't have maybe YouTube account, but it is my humble request to you. Please subscribe to the channel, so that the channel will go, so that I get motivated, right? And I'll be making more content for you. Different, not only cloud. You have already seen that I have created a advertisement on SAP that from 2nd January 2023 I'll be starting teaching SAP. Do you want to learn world's #1 ERP, which is SAP, and it was #1 from last 2 to 3 decades, and it is dominating the world. Okay, so yeah, we are going to learn SAP very soon from next year. So please subscribe to the channel and stay tuned. All right. And also, I have seen some requests from my friends. They have personally asked me to create the videos on Hindi. I don't have any plans right now, but I'll definitely think on that, and I'll do something. I don't know what to do right now. If I create the videos on Hindi, because we have Hindi audience also, I don't know whether I need to put these videos in the same channel, or I have to create another channel called IT Career Hindi. As this channel is a brand new channel. It's just a month-old baby. So I have no idea right now, but definitely I'm going to think on that, and we'll update you soon. So friends, let us not waste more time, and let us jump to today's lecture, which will be on compute service option in Google Cloud. All right. So what do you need to know whenever we are thinking about a data center and cloud? Like we have already discussed in our data center and cloud computing about what you need. So suppose you want to build a data center or think of a cloud. What are the things it is needed, right? So data center or cloud computing, right? What do you need? So you need a servers, first and foremost thing, right? Servers, which are virtual machines, right? It can be physical, it can be virtual. So these are compute, right? What is compute means? Compute means like computation, right? Like which will compute your logic, your application, where you will run your application. So you need the server. So in the server, what you have RAM, means memory, you have CPUs, right? And then you have other peripherals. What is the next thing you have? What else you need in the data center or cloud computing? You need storage, right? Definitely you need storage, right? Where you store all your data, your files, your all the database, all the data files, right? And third thing is databases. All right. And fourth thing is network. Without network, nothing will work, right? So you need the compute to connect with the storage, right? You need hard disk, external SSDs to be connected to your virtual machine. So you need network, right? Without network, you cannot do your virtual machine of the application connecting to the database. You need network, right? So in network is very essential. All right. And also, if you're thinking of the cloud computing, so suppose this is cloud, right? And this is you. Okay, this is you. So you are accessing the cloud through the internet, right? So you need a net. So net is important. And if you're thinking about the cloud, you have a special services. What are those? Those can be artificial intelligence, machine learning, and so many other things. So these are the special services which you may not get in the data center, but I'll not say may not. It means it will take a lot of, you need to spend a lot of money for that, right? So these are the things you need to have in very basically to run a data center or cloud computing. So compute, storage, databases, network, and special services. Right. So today's lecture is on compute. All right. So today's lecture is on compute. So let us go back to our slide and let's see what we have today. So in the compute service, so do you see this picture? In this picture, you see that the left hand side, the Google Compute Engine, and then we have Kubernetes engine, we have App Engine, we have Google Cloud Functions, right, and Firebase. So this arrow and this arrow, these two arrows, you see that the more left you go, you have more highly customizable, right, and more right you go, they are highly managed, and also more flexibility in the left side, and right side less flexibility. What does it mean? It means highly customized. So the compute engines, okay, the compute engine, which is is responsible for creating the virtual machines. So once you have virtual machines, you have more flexibility, and you can customize the virtual machines, like what you want, So where did my cursor go? So in the compute engine, we have virtual machines, and virtual machines, you have your own control. You just create it and you can do whatever. We are going to, in the following slide, we are going to talk more on that one. Whenever we are talking about Kubernetes engine, this is, we have container here. Okay, so this is container engine. Okay, so you can say Kubernetes engine also. GKE is, Google Kubernetes engine. So you have containers, you are managing, right? And what is highly managed? These are the ones will be managed by Google. The hardware, you are unaware of the hardware. You don't have to deal with the hardware and all. So all these things we are going to talk or discuss in our today's lesson. All right. Let us move to our next slide. Okay. So compute engine. What is compute engine? Compute engine is a service that allows user to create VM. I told you. So compute engine is nothing but it is a service to create VMs. Okay, it will allow you to create VMs and attach persistent storage to the VMs. So what is persistent storage? Persistent storage are nothing but like okay, example, VMs are like your laptop or desktop. So suppose you have a Windows desktop, you have C drive, and you have sometimes you request for more drive, right? E drive, F drive. So all those E drive, F drive are persistent storage. C drive is attached to the VM, or your with your laptop, right? So that is your boot disk, okay, where your operating system boot right there. And the persistent storage are the additional disk you need. Those can be SSDs and HDD. We are going to talk on this detail in the following following lectures. Okay, before I continue, today's lecture on all these compute engine, Kubernetes engine, all these things are very high level. I mean, it's not high level like other trainers are training in the beginning of the Google Cloud examination preparation, but I'm going little depth, but not that deep, because in the following lectures, after 2-3 lectures, we'll be going very deep dive into compute engine and creating very in depth, and also Kubernetes and every service of Google. All right, so you understand persistent risk. So compute engine will create the VM, and it will allow you to attach persistent storage to the VM and make use of other GKE services such as Google Storage. What is Google Storage? We are going to discuss this very soon in the next lecture. Okay, so virtual machine are basic unit of computing resources, okay, and good starting point for experimenting with the cloud. So it's saying it's a very basic. So actually this is a very old method of virtual machine. Very old terminology. Every cloud provider or VMware, they use virtual machines are very, very basic, okay, from where everything started. After you create an account with the cloud provider and provide billing information, you can use a portal or command line tool to create VMs. So it's saying, so I'm going to do all these things, guys, for you. Okay, we are going to create a account in front of you, and we are going to provide some billing information, and after that, once you logged into the Google Cloud console, you will be able to create virtual machine using command line as well as a portal. Okay. Google Cloud platform offers a variety of pre-configured VMs. Okay, so they allow very pre-configured VMs, varying number of vCPUs, okay, and amount of memory. So Google provide pre-configured VM so that you don't have to create it. These are standard VM. You can also create custom configuration if the pre-configured offerings does not or do not meet your needs. So as always, every company gives the standard, right? Once you don't have the standard, if your requirement does not meet the standards, you can always create the custom one. Like Google, suppose Google given you one CPU, okay, and vCPU if it is VM, right, and 28 GB RAM, okay, and it another one is 2 CPU, okay, and 48 GB RAM, okay. Suppose it's the standard and it does not fall into your requirement, you can definitely create your own custom machines. All right, so that is what they're saying. Okay, where is my cursor go? Okay, once you create a VM and logged into it and administer it, you like it, right? You have full access to the VM, so you can configure the file system, add persistent storage, patch the operating system, right? Install additional packages. So once you create the VM, it is like your desktop or laptop, right? A workstation. You log into it, administer it. You like whatever you like, or who else you want to give access. You can configure file system. You can, in case of this is a Unix or Linux server, and you can add persistent storage additional. Patch the operating system. You want to definitely you have to time by time you have to patch the operating system, or you can install additional packages, maybe Node.js, Python, Ruby, all those packages you want to install. You can install. It's you are the owner, you are the boss of that virtual machine. You decide what to run in the VM, who else have access to it, right? You decide. I mean, what to run in when and who has access to that. When to shut down the VM and when to stop the VM, right? And when to start the VM again. A VM that you manage like having a server in your office that you have full additional administrative right to. So you'll feel like you have a, although it is a cloud VM created very remote place, but you will not feel that this VM you are accessing from your office. It will look like you have a server in the office yourself, right? Adjacent to your your desk. All right. VM came in a range of pre-defined sizes, but you can also create customized configuration, as I mentioned before, right? They have a predefined sizes, but you can customize them. When you create an instance, you can specify a number of parameters, including the following. You can specify what operating system you want, size of the persistent disk, additional GPUs, graphical processing you need for compute intensive operation like machine learning, making the VM preemptible, right? So what are these things? So you decide whenever you are creating the VM, you have the option you want Unix, or you want Unix, or you want Windows, okay, or you want Ubuntu, you want CentOS, you want Debian. These are all operating system. Okay, if you have not heard about these operating system, you are going to learn them. Learn them. You don't need to learn all those operating system, but you are going to know the names of these. Okay, Ubuntu, CentOS, Debian, Linux, Unix are very famous, right? Windows, of course, famous. And the second one, the size of the persistent storage. So before starting any project, you have to do sizing, right? What should be your VM size? What should be your database size, right? So based on that, you decide. On the sizing, that how much CPU you need, how much memory you need for that particular VM, what is going to run into that depends on that. What should be the disk size? Suppose you want to install an application where only 50 gigabyte storage is needed, but you did not do any sizing and all, you blindly allocated 500 GB. But tell me, 500 GB cost you more than 50 GB, right? Where 450 GB is more, and it will go in vain, right? You are not going to use that, but you have to pay for that, right? So all these things has to be taken care before you create any VM or while you size it. Okay. Additional graphical processing unit GPUs for machine learning and all. Okay, there are special kind of virtual machine are available parameters. You need to have more GPUs. Okay, you have to add GPUs. For normal day-to-day operation, we don't need GPUs to be added. So those are different kind of. So we are going to learn more about these things in the following section. Following lecture after a few lectures. And making VM preemptible. Preemptible VMs are like it is given in the below. The last option, making VM preemptible, means you may be charged significantly less for the VM than normal. Okay, so normal VM, whatever you have, it is significantly less charge for preemptible, around 80% less. Okay, so it is very cheap, but your VM could be shut down anytime by Google. Okay, it can be shut down by Google anytime. So they are running only for 24 hours. Okay, so it will be shut down if the preemptible VM has run at least for 24 hours. Okay, so you cannot rely on to that. But why they have given an option? If the VM you created today preemptible VM and it may be shut down in 24 hours after, so there might be situation you want to test something, test a job. Okay, let's for example a job, and you want to test the load of the job, and you don't have any other capacity in your existing. In that case, just use to test a job for an hour or 2 hours or 5 hours, right? You need just build a preemptible VM and just test it there and then destroy it once you are done, right? So that's what it is talking about. All right. So let's go and let's understand the virtual machine architecture. So this is the virtual machines architecture. You see in the picture, the boxes, the colored boxes, right? I mean yellow, green and red. These are the virtual machines, and they have applications running on them. In this picture, there are 3 applications in each block, but you can have how many you want, depend on your size of the VM virtual machine, right? You can have multiple. Now here it is saying guest OS, Ubuntu Linux, guest OS 2, Apache Linux, guest OS 3, Windows Server. So it can be anything, it is of your choice. And it is saying guest OS for you are the owner of this one, right? Of this OS, you are the administrator of this, I mean VM or this VM. You log into this using a PuTTY, the tool PuTTY, or Windows VM through RDP. For you, this is not a guest OS. This is a operating system for you, right? Why it is mentioning guest here? So that, let us understand the architecture of that. So this is actually the physical server. The whole blue box is a physical server. And on top of the physical server, you have host operating system. Okay, you have host operating system like maybe Linux or Windows. All right, and on top of that, you installed hypervisor. Okay, now what is this hypervisor is? We never heard about it, right? Don't worry about it. I'm going to cover what is hypervisor here. Your doubts will be clear. If you want more detail, I can talk on hypervisor for an hour, and we can have another session specially for hypervisor. All right. So hypervisor is also known as virtual machine manager. Is a type of software that allows to create and manage virtual machines. So hypervisor is nothing but it is a software you install on top of the host operating system, which is installed on the physical server, which hypervisor is responsible for creating the VM. The VM will be created by them and also managing. Okay, I mean they need to make distance. They have a this VM should be independent of this, and this should be independent of each VM is independent. So it will manage. If the VM goes down and all, hypervisor will know about it. So everything, all management and creation will be taken care by the hypervisor. This hypervisor was invented long back in 1960s by IBM, and it was intended to be used in IBM's mainframe computers. But with that, when the world of cloud computing took off, more companies such as VMware, Microsoft, VirtualBox began producing hypervisor products to offering both home products as well as enterprise use. So in the home computer also, you can install hypervisor, and top of that you can have multiple virtual machines. Okay, and also this is an example of enterprise, right? Use. So what you do on host operating system, you install the hypervisor. So virtual machine. Now let's come to virtual machine from the front end. I mean, whenever you are administrator, from the front end, when you log into the Windows server and you log into a normal machine like in a workstation, you will not feel any difference. Okay, they both operate the same. Look wise and operation wise look same. Okay, but in the back end level, it is very different to the regular computer. All right, the virtual machine, the virtual machines are different to the regular computer. A regular computer has hardware supporting it to 1:1 ratio. Okay, let me go back to my whiteboard. So let's take an example of a regular computer. This is your regular computer. Okay, it has one CPU, right? You had CPU, it has RAM, it has disk. All right, they are 1:1 ratio, 1:1 ratio, right? It has typically has a CPU, memory, and hard disk, all entirely dedicated to supporting it, right? There is 1:1 ratio. But Virtual machines are simulated computers allowing multiple of them hosted on one set of hardware. So you have a one set of hardware, and on top of that you have a host OS, right? And you have a VM1, VM2, VM3. Okay, they are simulated computers. You got it, right? For the VM to be created and managed by the hypervisor, so you have a hypervisor, right? Hypervisor. Okay, software has, so to create the VMs on the host OS, you need to install the hypervisor. Okay, so that you will come to know, you will confirm that the virtual machine can be run on the this hardware. Okay, so hypervisor is playing a crucial role for virtualizing the hardware resources and component of the host computer so that the VM can be supported by the hardware. Alright, I hope you guys understand what I mean to say about the virtual machine. If you have any doubt about the virtual machines or the hypervisor, you can write in the comment section and I'll clear your doubt about the hypervisor. So it is nothing but a piece of software you install in the operating system, which can be on Linux or Windows, and this will be managing or creating the virtual machines. Now let us read the text here. Hypervisor run on operating system like Linux or Windows server. I mentioned it before, right? It can run this host operating system, can be Linux or Windows. Now it is saying hypervisor can run on multiple operating system. Okay, can run. So it's saying now hypervisor can run multiple operating system. You can see here we have a Ubuntu Linux, we have a Alpine Linux, we have a Windows server. Alright, while keeping the activities of each isolated from other guest operating systems. Right, so they are, I mentioned it before, that they are isolated from each other. No one is talking to each other. They are very independent. Okay, they even doesn't know like this is the adjacent adjacent VM to this VM, right? So every VM has an IP address and host name. Okay, each instance of an executing guest operating system is a VM instance, so they are also called VM instance. So I hope your doubts are clear now. Okay, let us move to next one. So what is the next compute engine service? Kubernetes engine. So Kubernetes engine is designed to allow user easily run containerized application on a cluster of service. Okay, so it is designed. So now what is these are heavy terms, right? If you are not aware of containerized, right, cluster, then pod, those things are, if they are new to you, don't worry, this is high level, this is a very high level lecture on the Kubernetes engine. Okay, by the way, Kubernetes is also called K83. Wait, hold on. Let me take the right K8S. So what is K8S? So this name is too long, right? So what they make K, and then there are 8 characters, right? From U, 1, 2, 3, 4, 5, 6, 7, 8, and then lastly S. So that's why K, 8 and S. Okay. Containers are often compared to VM. Okay, so VM we just discussed before the previous slide. What is VM, right? Like a server, like your workstation, right? So containers are often compared to the VM. Okay, why? We'll know. Because they are each used for isolating computing, processing, and resources. Okay, VMs are also isolating, right? But and this is a containers also. We are going to learn what it is isolating. Containers take different approach than VM for isolating computing process. All right, what is that? We're going to discuss. As mentioned, a VM is a guest operating system on a physical server, right? We mentioned it, right, in the previous slide. It is a guest operating system. Physical server runs an operating system as well. Okay, so in the VM, what happens? We have two operating system, right? Let us go back to our whiteboard. 1 minute. Let me take it to. Okay. Whiteboarding is very easy. So this is VM. Okay, so this is physical server, right? And on top of that you have host OS, right? Host OS, right? And on which can be Windows or Linux. And on top of that you installed hypervisor, all right? And top of that you install the VM1, VM2, VM3, VM4, blah 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 blah. It depends on what is your host operating system's capacity. Based on that, so here you allocate each, CPU, vCPU, memory, right? Each one has its own. So you cannot allocate here, in this ones more than whatever you have. So this host, physical server has suppose 200 CPUs, right? So these 200 should, the host OS itself needs something, right? And whatever is left, you can distribute into your VM. You cannot create more than that, right? So this is the load will be distributed like this. So this is, so in the VM you have two OS. So here also you have guest OS, right? Suppose this is Windows, this is Unix, Linux, okay, this is Ubuntu. Okay, now if we are talking about containers, so containers play little different here. So here, this is what they are saying in the slide, that physical server run on operating system as well. Okay, after another approach of isolating computing resources is to use feature host operating system and isolating the process. Okay, so here let us read it from before, from beginning. As mentioned, a VM runs the operating system, guest operating system in the physical server, right? And physical server runs on operating system as well, right? We just mentioned, along with the hypervisor. Yes. Another approach to isolate computing resources is to use feature of the host operating system to isolate processes, okay, and resources. So here they are isolating the virtual machines in the VM, and now here they are in the containerized applications, they are isolating the processes and resources. How? Like we are going to know. So this is the picture, and we are going to learn about what is this. So here in the containerized application, you see that there is a container manager instead of hypervisor. There is no hypervisor concept. Okay. With this approach, there is no need of hypervisor. See, there is no hypervisor. The host operating system maintains isolation. Instead, a container manager is used. Okay, container manager. That is, a single container manager coordinates container running on the server. Okay, a singular container manager. So you see there are like VM. There are multiple containers, and you have multiple application, and there is no OS here. There is no OS here. Okay, there is no guest OS here. So you know, right? Any operating system you install in any server, or let's take an example of your laptop or desktop. You have a 4 GB laptop. Out of that, you'll find that you you have available 1 GB or 1.5 GB or 2 GB maximum, because 2 GB memory consumed by your operating system, which you which you didn't use. Out of 4 GB, 2 GB eaten by operating system itself. So these are very highly consumed processes from the operating system, right? So this concept came, and this is better than the other one. But we are going to talk about more about it, how it is better or whether it is better. So in not all the case, Kubernetes engine will not work. So it is not like VMs are bad, or we still need VM. But this is the purpose of something else, some kind of different application. This is better. Okay. No additional or guest operating system runs on top of the container manager. I mentioned it already just now. Instead, container make use of the host operating system functionality. So container use the host operating system's functionality itself. So you have host operating system, and so it uses this operating system itself. While the operating system and container manager ensure isolation between the running containers. So container manager and host operating system, they will ensure the isolation should be made between the containers. Okay. Kubernetes engine is a GCP product that allows users to decide the compute, storage, and memory resources they would like to run on their services. So you know what, this Kubernetes actually it is invented by Google itself, and then they made it open source to the world. Okay. And Google is very good at Kubernetes. Kubernetes, of course Google invented, so they have a very grasp onto that one, right? They have a very good understanding of that one than any other provider. So it is GCP product and allows users to describe the compute, storage, and memory resources they would like to run in their services. Kubernetes engine then provision the underlying resources. Okay. So Kubernetes engine will provision that underlying resources. It's easy to add and remove resources from Kubernetes cluster using command line interface or graphical interface. So the beauty of Kubernetes or clustering thing is you can scale up and scale down easily. Okay. You can do it by graphical user, GUI, the front end, or you can do the command line interface. In addition, Kubernetes monitors the health of the server of the cluster and automatically repairs the problem, and such as failed server. So that is called self-healing. Okay. So it will once it will find the faulty server, it will build another one. Okay. So it will automatically monitor the health of the servers. Kubernetes engine also supports auto scaling. I mentioned it just now. Okay. So if the load of your application increases, Kubernetes engine will allocate additional resources. I mentioned it, right? So it means what? When the load is more, suppose, okay, let me give an example. Suppose there is a game going, cricket match or Super Bowl, right? And there are millions of people are watching it over the internet. And now, whenever the match started, you have many people, millions of 1 million people, started the streaming. That time, if your server capacity is not good, then the server may crash, right? Or may hang. So in the case of Kubernetes, what Kubernetes does, Kubernetes is nothing but it's an orchestration tool. It is just containerize, it is orchestrate the or administrated the containers. So whenever the crowd or the in the internet, more, from 1 million to 2 million within certain time, what it will do, it will auto scale to the number of, to number required for that number of people. When the match is over, it will scale down the number to whatever it was before. Okay, so it will horizontally grow, and and it will shrink also to the same position. Okay, so it has this this beauty, this feature. That is, nowadays Kubernetes are very popular in the market. So web services are best to deploy in the Kubernetes, so that if you have a high traffic, you don't have to manage by yourself. Okay, we have more traffic, you monitor and then you add up space and all, or increase the memory, CPU. No, you don't have to do it. Your Kubernetes engine will do for you. All right, auto scaling up and down. So a container is like a lightweight VM that isolate processes running on one container from processes running on another container in the same server. Okay, so it is like a lightweight VM, because VMs are heavyweight, right? Because it has an operating system. This does not have an operating system, so it is a lightweight. So they are isolating to with each other. The process, although they are running in the same server, same operating system. Okay, don't worry about it. I know you may have some confusion still, but this is very high level. Okay, we are going to very deep dive into Kubernetes. After my lectures, you are going to be very pro into this in this subject. I'm 100% sure, because in the following lecture after that, once you have the practical on the compute engine, we'll be doing all the VMs, different kind of VMs, all the types of VM with different configuration, custom and all. Then when we'll move to Kubernetes, we'll be having, I think, 3 to 4 lectures on that. So we are going to do that. This is high level. For now, you need to remember that Kubernetes are like lightweight VM, where it runs on the same operating system, host operating system, and on top of that we have a container manager, and container manager and operating system maintains the all these containers, and they make them isolate. Okay, and it does not have guest operating system. All right, so let us move to our next one. The next computer service is App Engine. App Engine we already discussed, just a little, like it is a PaaS solution, platform as a service solution from Google. So and this is very highly managed by Google. App Engine is GCP's compute PaaS offering. With App Engine, developers and application administrators don't need to concern themselves with configuring VM and specifying Kubernetes cluster. All right. So, as I mentioned, this is a PaaS offering. So we remember we talked about all the Google services like PaaS, AS, and SaaS, right? So this is like a PaaS, right? So you don't have to do anything. It is like you are getting the platform, and you are just you means you as a developer or application developer, you don't need to concern about themselves with the configuring the VM, or you don't have to, because VMs are falling into the compute engine IaaS, right? Infrastructure as service, or specifying Kubernetes clusters, right? Again, Kubernetes, where Kubernetes falls, PaaS, AS, or SaaS. This is called CaaS. This is a new term, not new, but it is not that in a trend like it has infrastructure or platform or software as service. CaaS is container as a service. Okay. Instead, developer create application in a popular programming languages such as Java, Go, Python, or Node.js, and deploy the code to a serverless application environment. In the cloud, you are going to hear this serverless word a lot. Okay, so what is serverless? Serverless, it doesn't mean it's a server in the backend. Definitely some server is running, right? Okay, there is no ghost here. So serverless means for you as a developer, you have the you have a Python code or a program ready. You just need to deploy it into the compiler. So they provide you everything. So the infrastructure and everything. So that's why for you as a user or a developer, it is serverless for you. Okay. App Engine manages the underlying computing and network infrastructure. We already talked, right? App Engine manage means Google manage, right? There is no need to configure VM or harden networks to protect your application. So no VMs need to be created. We already talked. App Engine is well suited for web or mobile backend application. Okay, so App Engine is, if you want to create a web application, App Engine is the very best. Okay, and backend application, any mobile backend application you want to create, App Engine is the best thing. Last but not the least, Cloud Function. Cloud Function is a lightweight computing option that is well suited to event-driven processing. So what is event-driven? Event-driven is something like an event happened, some event happened, and it will trigger the function. So that for that one, we use the Cloud Function. So Cloud Function runs code in response to an event. Remember, okay, like a file being uploaded to the cloud storage or a message being written to the message queue. So whenever as an example, whenever a file is stored, uploaded into the cloud storage and some directory, there should be an event created, and that will trigger some other function, and that function will do something else, right? So on an event base, or message being written in a message queue. Okay, the code that executes the Cloud Function environment must be short running. This computing service is not designed to execute long running code. If you need to support long running application jobs, consider Compute Engine, Kubernetes, or App Engine. So as we mentioned, this is just an event driven function. That there should be very small, short running. Just trigger it. Okay, so an event happened and trigger. So for long running and all, use App Engine or any one of this, the previous ones, Compute Engine or Kubernetes, depends on the requirement. Like App Engine, Cloud Functions is a serverless product. Yeah, same way this is also a PaaS. Okay, users only need to supply code. They do not need to configure VM or create containers. Okay, same way like App Engine. Cloud Function will automatically scale as load increases. So same way like App Engine or the containerized application, it will automatically scale up or scale down based on the load increases or decreases. All right, so that's all about today's lecture. Google Compute Engine options we have. So in the next lecture, I'm going to go through the decision tree. How you, I don't want to make this video very long, and let us wind up here. We are going to how you decide what to use, what type of application use Kubernetes engine, what type of requirement use Compute Engine, for what purpose you will what type of project you will App Engine or Cloud Function. So there is a decision tree. So based on that, we are going to discuss in the next lecture. So with that said, that's all for today. Please subscribe to the channel if you have not done yet. Thank you so much. Like the video, and if you have not shared this channel with your friends and families, please do do as soon as possible, and I'll promise that I'm going to create more videos like this and continue. I'll not stop. So thank you so much for watching my videos. Have a nice day. Bye bye.